Blizzards by Lorraine Jean Hopping. Chapter 3, Superstorm. Blizzards are common in Canada and north-central United States. They often visit northern Europe and Russia, and they are right at home on mountains and in polar regions. But people in warm climates aren't totally safe. In 1993, a blizzard known as Superstorm stretched from Vermont to Florida. 60,000 flashes of lightning hit the ground. Tornadoes spun out of the clouds. Few blizzards have lightning and tornadoes. Superstorm, 1993. Here's Florida. All the parts that are shaded is where the superstorm went, and here's where blizzards frequently are. About 270 people died in Superstorm. Many deaths were in southern states such as Florida. There, people were less prepared to cope with a blizzard. Why do killer blizzards form? In 1888, people had no idea. Many in our class didn't know what hit them. How could the temperature drop 50 degrees in a few hours? Why did the wind grow so fierce? Weather scientists have found some of the answers. In winter, Arctic air masses sweep into the United States from Canada. They can travel as fast as a speeding car. At the same time, warm air masses enter the United States from the south. They are bursting with moisture. What happens when the two air masses crash? Instant winter storm, cold, wind, and snow. The temperature drops as the Arctic air pushes the warm air out of the way. Cold and warm air swirl around each other. The lighter warm air may roll over the heavy cold air. The cold air may push the warm air from below. We feel this moving, shoving, swirling air as wind. As the wet, warm air cools off, the clouds shrink. The process is similar to squeezing a wet sponge. Shrunken clouds can't hold as much moisture, so snowflakes or ice crystals fall out of them. After a blizzard, the wind stops. The temperature may rise. Only the snow remains to cause more life-threatening problems. Diagram showing the warm air being pushed up and the cold air going under. And then you can see snow. Chapter 4, Mountains of Snow. Storms pick up moisture as they pass over lakes. Then they dump the moisture on areas near the lakes. Buffalo, New York is one of these lake-effect cities. In a 1977 blizzard, snow drifted 30 feet high there. That's enough to bury trucks and entire houses. The drifts were so high that deer escaped from the zoo. They simply walked over the snow-covered fence. Buffalo residents shoveled up to 4 tons of snow per driveway. Showing us where Buffalo, New York is. The green is Canada. It's very far north. And then here's like a snapshot of what it would have looked like there. The snow all the way covering that car. In January 1996, snow on New York City streets was piled high. Cars were buried. There was no place left to put the snow. For days, dump trucks hauled snow out of the city. Giant snowdrifts don't just cause problems in cities. A farmer named Brad Olson almost got clobbered by one. A 1997 blizzard in Minnesota dumped 20 inches of heavy snow on his barn. Brad ran out of the barn seconds before the roof fell. There's his roof falling. If blizzard snow melts, floods may take more lives or ruin more property. Even if the snow doesn't melt, it creates a hazard on mountains. There, blizzards pile snow at steep angles. Picture a pile of flour on a cookie sheet. Lift one end of the sheet higher bit by bit. At some point, the whole pile slides down fast. Lots of snow sliding or falling down a slope is an avalanche. The snow can travel faster than a speeding train. Skiers, climbers, and others in the area can get buried. Look at the avalanche. You got from the start, and then Chapter 5, the next big blizzard. How can we know for sure when the next blizzard will hit? Scientist John Cortines asks that question every day, but he can't always answer it. Not even the biggest computer in the world can be 100% sure of the weather. John works at the National Severe Storms Laboratory in Oklahoma. He studies past storms for clues that signal a storm is forming or changing. The clues might be a certain mix of temperature, wind speed, air pressure, and humidity, wetness. Scientists at the National Weather Service look for similar clues in current weather. They study a computer weather map like the one at right. Then they enter all the data into a supercomputer. An hour or so later, the computer makes a forecast called a model. The model shows how weather is likely to change over time. For example, it might predict temperatures 12 hours into the future. Models aren't always right. In fact, models from two different computers can disagree. So it's pointing to a rainstorm. Here is a front where cold and warm air masses meet. And high pressure area, which means good weather. In January 1996, one computer model showed heavy snow heading for the northeast. Another called for light rain. It predicted the storm would stay at sea. Weather forecasters believed the model for heavy snow. They put out a winter storm warning, and they were right. How did the scientists know? The forecaster has to look at all the data, John says, not just the computer model. All the data includes models, radar images, and weather readings from around the world. John's research on past storms helps forecasters make sense of all this data on current storms. Does a certain radar pattern mean a storm is getting worse? How can we tell if a storm will suddenly change course? What happens when a storm moves from sea to land? The more answers that scientists find, the more certain forecasters can be. They can confidently say that a blizzard is or isn't on the way. Blizzard tips. In cold weather, always wear a bright coat, 3 layers of clothes, mittens, boots, and a hat. Never go off alone. A blizzard watch means a storm may form. A blizzard warning means a storm is on the way. In either case, stay inside. If you are stuck outside, stay in your car or find shelter. Put a bright object where rescuers might see it. Keep moving, clap your hands, jump up and down, and don't fall asleep. The end.